So without further ado, let me pass on to Rafa.
Hi, my name is Rafa. I don't use FreeBSD. Sorry. I've been working with Sasha said in TVP for 11 years, and I will tell you how to do live events. Let me see which one is it. Okay. So first-hand experiences of the 2014 FIFA World Cup finals in Brazil. And this goes for Euro broadcast in 2016 and works for the finals that just lately ended in 2018. So for 11 years I was working for TVP, and we started in 2004 in pre-smartphone era. In fact, in the first year when I came to TVP, guys came to me and said, check out this new site, YouTube. There are a lot of videos there. So we started before YouTube doing broadcast. The first broadcast was actually from the funeral of the Pope, I believe. So we did all the Olympics since Torino in 2006 and up until Euro 2012. And in 2006, we did a full PAL 576p broadcast, and in 2005, a year before that, we did a surround sound broadcast, which was the first one in the country. So I tell you how to bring a match straight from the field into your laptop or cell phone or tablet screen. So you need to capture the stream, you need to prepare it, and you need to broadcast it. So for capturing the stream, this year it was done from Moscow through a fiber link down to Warsaw, and there was a backup link using satellite, and there was a big broadcasting center in Moscow, where the 12 venues were getting into one point. OBS was responsible for the broadcast, for the managing the broadcast. OBS is Olympic Broadcasting Services. It's a subsidiary of EBU, European Broadcasters Union, and the link was from Moscow down to Geneva when everything was managed. It was like 2,800 kilometers straight. And from Geneva, TVP got the signal to its HQ here in Warsaw with the fiber channels, fiber links. The signal was 4K, 16 4K signals, and 8 HD signals upscaled to 4K. TVP got 24 simultaneous, 24 links at once, and it was able to. OBS was getting 24 links, and it was managing the broadcast and choosing the right angle to show. So this is Sorry, it was. It's very. I expected a bigger screen. So, what is SDI? SDI is a serial digital interface. It's like Ethernet for broadcasting. It differs in principles. Like in Internet, you don't care. You care much about what's inside the packets. In SDI, you don't care about what goes in the packets. You care where the signal goes. In SDI, you mostly do static protein-based routing, and in Ethernet you do dynamic routing based on BGP or something. Mostly you still use broadcasting guys still use BNC connectors for a physical layer, and the gear to handle the broadcasting side of the of the of the picture is very expensive. Like it costs a fortune. So SDI was introduced in 1989. It's 270 megabits per second. It contains all the signal that there is in the video picture, including the color burst, the VSync and HSync signals. So it's a digital representation of the picture that goes analog picture that goes that is processed. And in 2002 and 2006, HD version of SDI. No, in 1998, the HD version of SDI was introduced. It was 1.5 gigabits, and in later it grew to 4K HDI, 6 gig and 12 gig variants, which will handle 2160 by, I don't know, 3840, something like this. So it's 4K broadcasting is done with 12 gigabits in four, usually in four fiber links. So getting back to the way it was done. From Voronica, the HQ of TBP, the solo, they call it solo, so it's just the plain picture with sound from the field. It was it was transferred to the broadcasting guys. They routed the signal to Studio 7 and Studio 1. The Studio 1 was the main studio for doing the broadcast. Studio 7 was the small studio with commentators. And there was, when the studio processed the signal, it was split into broadcasting facility, into PVR for recording, for VOD, and 2 Caspars. And I'll tell you what Caspar is. So when you get the signal, you have to prepare it. So in 2014, we used Cisco gear. Now we use some other stuff, but Cisco was mainly for archival purposes, and we used this kind of gear. It is very expensive. Actually, it's a Linux box with some proprietary software, and this one is a newer version of encoder than this old Cisco, and it's also Linux box with some proprietary. I believe it's FFmpeg in there. So this 12 gig SDI was then processed by this gear, and it was turned into multicast. And it was available in the local Ethernet network that was attached directly to the servers. So Caspar CG was used. Caspar CG is a free broadcasting software developed by the Swedish broadcaster, national broadcaster, and it works with a cheap video card and a cheap PC hardware. So we call it Składak, which means DIY computer. Yeah. So it was used to convert the multicast HD into HLS, which with about 4 or 5 substreams. Every licensee was obliged to add a special logo for the broadcast. And during the break, the signal was mixed with the jingles, or before the match, there was signal directly from the venues with no comment put into just internet an hour before you could watch what was going on the venue. So it was a very well unprofessional setup, but it works. It was a L-word operating system with specially crafted FFmpeg doing the processing. And in this particular machine, we had one GPU, which was doing the H.264 decoding. We had Decklink Duo, 2 inputs and 2 outputs. We had another Decklink card doing another HD broadcast, and it was just one CPU, and most of the work was done by the GPU. So, dobra, okay. Okay, so this was the setup, and then you have to broadcast it. So the marketing guys set up this web page, easy to remember address. 2 days later, they asked us to turn this into video. So just to tell you how much effort goes into organizing and doing this, these are 64 matches. And in 2014, it was all squeezed into, I don't know, it was like 14 days. This year we had longer period of the group session, but it also this year it was also 64 matches, and those matches in the last, I don't know, 4 days, they were broadcasted side by side because of the way the finance work. And this is what you usually have. And to tell you the truth, this is what you need. This is a Google data center. And yeah, we bought some hardware, because when you need speed, you need real hardware. Virtual machines does not work for this, and every megabit counts. So, and also you need some nice network stuff. 2 years ago, we tried the 14 gig NICs, and we borrowed this nice switch. And in 2014, we were the first ones to receive 100 gig network card for Cisco routers. We had it for 2 weeks or a month, and Cisco came screaming into us that they have customers waiting for it, and we just ran some tests. But this year there was 200 gig 100 gig uplinks, and probably 4 or 6 40 gig uplinks from directly from TBP's HQ. So basically, you need gear, you need CDN, you need lots of gigabits, and you need luck. So 2 years ago, we had, well, 50 plus servers. This is Ganglia doing the statistics for all those servers. And to set it up and to manage it, you need a lot of Ansible, a lot of luck, and a lot of work to get it done. And a CDN, well, maybe not, I won't be reading this. It will be available on the web. But CDN is a content delivery network which handles the delivery up to your computer. So it consists of redirector nodes when all the magic happens, the proxy nodes, edge nodes, and origin nodes. So you can pay a lot of cash for Akamai CDN or level 3 CDN or Fastly, or you can just spend about 5 years, $1 million on €1 million, and 12 people doing this, and TBP did this since 2008. It was developing its own CDN, and when you develop your own CDN, you pay just for the running cost, and it's just 1/3 of what you usually pay to Akamai and CDN providers. So you've got this nice web page with links to live stuff and unique luck. Because the first thing we did with the first match in 2014 was this. Well, nice errors showed up on user screens, and we didn't know what was going on. It turned out that hosting was the problem. We put a lot of effort setting up CDN and the nodes and making sure that the pipes with network were wide enough, but we forgot about hosting. So we turned into Cloudflare. I personally bought this Cloudflare account for $200, and we ran everything through Cloudflare. Every request to export BSD-PL was run through Cloudflare, and this is the cached content, and this is the uncached fetches. So it was more than 99% efficient. So in 2014, the finals, we did 200 gigabits for the match between Germany and Brazil. You may remember this because it was 7-1. Yeah, and the next match was even more people watched this. It was between Argentina and Holland, Netherlands, I believe. And the match later, nobody really watched the match for the third place. It was just 116 gigabits. And this was the main event, the final on the July 13th. And it was between Germany and Argentina. We did 2011 gigabits per second. So it turned out it was like more than 200,000 unique IPs IPs were registered during the broadcast. And from the broadcaster's perspective, every night in the group period looked like this. So these are providers. These are uplink to providers. I believe this is Netia. I believe this is UPC, and those are other providers. So as you can see, UPC saturated all the links that were going into UPC. Later I can tell you tales about getting along with UPC. But on the night of the final match, it was Netia that was almost saturated 100% of the uplink, and UPC, as always, was just flat. So Netia was very kind and lent us a network card for Cisco ASL router, so they were able to go for 30 gigabits. Not it was like something less before they lent us this network card. So when you have saturate the link, you get back picture, and you often have to reload the web page. So this is the diagram, the statistics from our servers. We were generating up to 80 gigabits in TVP, just TBP, and not counting other places. And well, this was an error in setup because this server shouldn't get this much traffic. Others should, but this server was, I don't know, had more and more power in getting stuff. So probably if we configure this right, we'll be able to feed more than we did. And we had just four servers in Plix. Plix is an IX in Warsaw. Is the biggest one. It does about 40% of the total internet that is going on in Poland. And those were just old 2011 servers with two 10 gig network cards. So on the night of the final, we ran the event, and most of the servers saturated the links except one. So it was very strange what was going on, because it should be like this. So we did what we should. In this case, we just rebooted the server, and later it went along the other servers, and it went smoothly up to the end. So at the last, I believe it was the end of the match. We did 211 gigabits from total from all the sources that we had. And if you're wondering what a server does in times like this, it does mostly IRQ. So most of the load is related to servicing IRQ, even though the network cards are offloading the TCP stack and everything to hardware. Most of the work is done with servicing IRQs. And just to show you that I'm not lying, this is ATOP tool for Linux, and we did more than 17 gigabits from one server with two NICs running not like special kind of software, but regular Linux with regular TCP stack. So 2 years later, we tried 40 gig cards. This is a Mellanox MCX card, very nice card, and we've got this switch that I showed you earlier. So this was one of the first cards that were available, and it ran just eight PCI Express 3.0 on using 8 lanes of PCI Express. So theoretically, you from a dual port 40 gig card, you should get about 63 gigabits per second. But actually, by trial and error, we find out that you only can do 50 to 55 gigabits per second. So a quick tip, if you're counting on aggregating link, your uplink with two 40 gig links, but use one network card, don't count that it will go more than 50 gigabits per second of transfer. And we had to disable tracking, session tracking with IP tables. And I wasn't working in TVP this year, but I know how it was done. Previously, it was like, let's see, 50 plus servers, right? And we were stuffing this in. Operator called us and told us that the uplink is saturated. So you have a server? Yes. give us SSH access, and we configured this server, and it offloaded their uplink. So this year, let's go back. Yeah. This year, it was just 12 servers. These are Dell servers, each one having two 40 gig NIC and two 10 gig NICs. So in total, you get about 100 gig capability. In fact, it was like maybe 80 gigabits. You were able to send 80 gigabits from this one server. And really, this setup did over 800 gigabits of real broadcasting. So in 2014, we did 2011 gigabits. In 2000, sorry, it should be 16 there. We did more than 400 gigabits, and I predicted that in 2018 we'll reach 800. And indeed, guys at TBP did 860 gigabits, and I can tell you, I didn't want to be on this presentation, but actually those servers did more than terabit of transfer, because NC Plus, the broadcaster, the satellite broadcaster, was also using those servers. So it was more than, I think it was one terabit, 60 gigabits of traffic. And that's it. You need a lot of gear, you need smart software, and you need a lot of luck to run events like this, and a lot of experience from failures that we had all along, from the first broadcast that we did for Torino 2006 up to this FIFA World Cup 2018. And that's it.
And efficient hosting.
Yeah, efficient hosting. Yeah, but by trial and error, you get the setup right. And from one server, you can do almost 100 gigs uplink with some network engineering. Thank you.